to those that have made it for the first ever script meeting for the developers on Bitcoin Cash. And I'd like to welcome you all here, and we'll start with some introductions, and then we'll go through some of the things that will be on the agenda. So I'll start with my top left, Antony Zegers.
Sure, yeah, I'm Antony Zegers. I'm with Bitcoin ABC. And I guess for the context of this meeting, I guess my claim to fame would be that I organized and helped coordinate the review, like the design review for check data sig to get that into the protocol. So that was my contribution to the script stuff.
Okay. Thank you, Antony. Moving along, Mark Lundeberg.
Yeah, Mark Lundeberg. I've been working on script ever since I got involved in Bitcoin Cash in 2018, early 2018. And I've been working on the upgrades also.
Thank you, Mark. Moving right across to Rosco. I don't know how to pronounce your last name, so maybe you could do that too.
Hi guys, Rosco Kalis with Bitcoin.com. I'm working on Cash scripts right now, which is a high-level language for script.
Excellent, thank you, Rosco. My bottom left is Tobias Ruck.
So I'm Tobias Ruck, or as I would say, Tobias Ruck. And yeah, I've developed a couple of smart contracts, including the SRP DEX smart contract and recently the B.Cash smart contract. And I've also proposed a new transaction version, which would make Bitcoin Cash more smart contract friendly in Australia. And yeah, I've posted that on YouTube.
Thank you very much. Moving on to Karol, and I will not try and pronounce your last name. My apologies.
Okay. Hi, I'm Karol Trzeszczkowski. I'm the developer of Last Will contract and Mecenas contract mostly. These are contract. I mean, Last Will contract was the first useful example of Covenant. I mostly work on top of Electron Cash, and yeah, that's my involvement with scripts.
Good introduction, thank you. Next on my right is Jason Dreyzehner, please.
Hey y'all, I'm Jason Dreyzehner, working at bitoff.com, which is a way to log into websites using Bitcoin scripts, using Bitcoin wallets. So defining constraints with the same way that we define constraints for Bitcoin transactions. Right. I also did cash channels recently, and I had written Bitcoin TS before.
Thank you, Jason. I think that's everyone that's on the call right at the moment. Next on the agenda is to ask Antony to give an explanation for the goal of the meeting and the background, please.
Yeah, so basically, what spurred me to like propose having this meeting was last week Tobias had brought up in the regular dev meeting, brought up the idea of increasing the limits on script. And he had also previously proposed up reverse, which was to change the endianness of numbers, which, I mean, both of those things are good ideas maybe. But I kind of realized that in order to evaluate things and figure out what we want to do in terms of the protocol, it's important to figure out an overall idea, like an overall plan, basically, of how everything will fit together. So I thought it would be good to get everyone together and come up with, I mean, we're not going to come up with a roadmap or something right now in this meeting, but at least come up with ideas and maybe a plan for how to come up with a roadmap or something like that. So yeah, I guess that's the basic gist of it. Maybe I guess my idea for the agenda, which is up to whatever everyone else wants to talk about, but I kind of see it in two parts. Like we have the incremental upgrades to what we have now, which is like adding opcodes or stuff like that. And then there's the more long-term ideas like Tobias's Nimbus and stuff like that, a new transaction format and things. So I thought it might be good to divide the agenda into those two into those two kind of categories, if that makes sense. I don't know. And yeah, I guess the main thing to focus on, like I guess the important part is also which things affect each other. So for example, changing the size of integers, like if we want to have larger integers, that would affect other things. Like I don't know if that would affect op reverse, the Indianness thing, but maybe, or it would affect op mul and how you handle overflows and all these sorts of things. So basically you want to make sure that like if we do things incrementally, that we don't do something that will come back to haunt us later. So yeah, I guess that's basically what the thinking was behind putting the meeting together, but up to whatever everyone else wants to talk about. Does that sound reasonable? I mean, I basically listed every proposal that I was aware of. So this is basically what I'm aware of. So there's one thing is bigger integers. There's op mul, which might be, it's like there's a few basic opcodes, op mul, reverse op roll, which is basically we have op roll. That's something that Peter Willa mentioned in a talk. So that's the compiler. Apparently it helps with compiler optimizations. There's the endianness changing thing that Tobias proposed. And then there's Jason Dreyzehner's proposed op push state, which is basically, or I guess I don't know, I don't think the name is decided yet. Maybe it's called op context or op tx info or something. But basically instead of, basically it would push information about the transaction onto the stack. There's things like increasing limits, like script size limits, opcode count limits. Oh yeah, and then that ties into a different, like thinking about attacks and mitigations. Like one thing we were talking about opcode separator, which causes problems. So maybe like making that non-standard was one idea that I think Mark had. Yeah, and then beyond that, it's pretty much like the more long-term stuff, like new transaction formats, like Nimbus and other ideas along those lines. That's all I have. So I don't know if there's more stuff out there.
I think we should start with the OP push state Jason proposed. I think we should just call it OP push state for now because the name is,
Sure.
Yeah, everybody's own opinion.
Sure.
Yeah, it makes it a little easier to find a discussion about it if we continue using like the working group name. But yeah, so it may be either a single opcode or as Tobias or Tobias, am I saying that right?
Whatever. Yeah. Both is correct.
How do you say your name?
I say Tobias. But...
Okay, Tobias. So as Tobias's pull request specifies a way of doing it with multiple opcodes, where there are a lot of additional benefits, like passing in to the index of various inputs and outputs and getting picking specific information from the transaction context. But yeah, so what? I don't know if I have much more to discuss directly about it. Are there? What's on the agenda to talk about for it?
Well, I don't know. I guess I'll give my ideas about it because I was thinking about this earlier today. Like when we did check data sig, one thing I realized during the design review is that it's basically the second half of op check sig. So you can think of op check sig as it takes a bunch of data out of a transaction, hashes it somehow according to the sig hash, and then checks the signature against that, where that's the message. So when we were designing up check data sig, I kind of thought, oh, it's kind of nice if check data sig is essentially exactly the same as the second half of up check sig. And I never actually didn't really have the idea at the time that covenants would be a thing. But I kind of thought like, oh, that's cool. You could take some other transaction maybe and put in the sig hash and check it in another transaction or something. I don't know if there's any use for that or not. But it just seemed like an interesting property that it has. And then I thought, oh, maybe in the future you could have like an op push sig hash or something onto the stack, which I guess that's a bad idea, like to push the whatever you call it, like the sig hash onto the stack, because I don't know, Mark can explain that better than I can. But there's some kind of, I guess it stops you from caching stuff easily. But anyway, so basically this stuff that Jason is talking about kind of, to me, fits into that idea, like, and it's actually way more powerful if you think about it, because rather than having a set of predefined sig hash algorithms, you could just push any data you wanted from there, and you could combine it in whatever way you wanted and check that signature. So basically, in concept, you could basically replace up check sig with like pushing whatever data is on there, to calculate the sig hash and use check data sig to check the signature against that conceptually. So I think that's kind of interesting. And then you could do anything you wanted rather than have sig hash flags. You can just, you can put whatever you want in the script to like do all kinds of weird stuff. Like you could have the no input, for example, or whatever. So anyway, it just kind of makes me, the fact that it's simple and fits in like that kind of makes me think it seems like it's the kind of thing where you think like, oh, this design kind of fits together with what's there. So yeah, that's just my overall impression of it.
I think I jump in here. So that's a very good introduction to the idea behind the opcode were proposed in the in the proposal. So I think there are four main proposals of how to do this opcode. So the one proposed by Jason is that you get a string of bytes into the opcode, and then each byte can have a special meaning, and then basically the opcodes for each byte, it puts in the specific thing that is represented by that byte. For example, the outpoint hashes, or the script code of the transaction, and all the stuff in the order specified. Then what's his name? Tendo Pine, the anime picture guy. He proposed to change that to a slightly different encoding, to use bit flags instead. That would fix the order, but would more or less be the same thing. So I thought about those two options, and for me it wasn't very clear why having the concatenation of the data from the transaction would be beneficial. And so far we haven't really figured out if there is an advantage to it. So I proposed another solution, and for that there are two variants basically. To instead use just a set of opcodes instead. My proposal was to use a multi-byte opcode. So we currently don't have any multi-byte opcodes in Bitcoin script. So we would have to change parsing of scripts, and that would be the downside of that. But it otherwise would be, in my opinion, more clear and simple. So it would, like, each opcode would also be able to take additional data as input, which wouldn't be per se possible in Jason's proposal, or it would at least be very it would not fit that well, I think.
It would require variadic arguments, which would make it really nasty, like op-check multisig.
Yeah.
So yeah, definitely would be nasty.
Yeah, that would be like the fourth solution, which Jason already described as nasty, which is like to make a variadic solution of, so we just have one opcode, which only has 1 byte, but it's then it pops an additional item from the stack that specifies the exact behavior of the opcode, and then it can or cannot pop more additional not opcodes, more additional stack items that specify an index or specify other behavior. I think currently it's just indices, but yeah. So I think those are the current solutions. There are some clear advantages to do it some way or to do it another way. Yeah, anybody want to follow up on that?
Yeah, it's an awesome description. Thank you. And I'll add like one further option is basically Tobias's proposal, except without implementing it as multi-byte opcodes. Since we have about 70 unused single-byte opcodes currently, if we talk about the kind of the ultimate purpose of script and conclude that we think we can get most of the rest done in 70 bytes, then it might not necessarily be ever needed to do a multi-byte system. And we probably don't need to optimize that yet, especially if under Tobias's, the stuff that Tobias was proposing in the PR that he sent, it would actually, in the original proposal that I spec'd out really quickly, I think I had 15 different state item identifiers, but I don't think that they would necessarily map to 15 different opcodes. I think that if we allow opcodes to take parameters and select specific things from the stack and stuff, there's actually not a reason to implement a few of them, because they would only be useful to implement in the check sig dupe check data sig covenant style, like using covenants where you check the signing serialization twice. But if we have these push opcodes that are pushing context information, then as Mark identified, they are already authenticated, so we don't need to check them again. So it may turn out that we don't even need some of those. Like one of them being like the prefix byte, the Bitcoin var int before the covered byte code, before script code, the Bitcoin var int describing the length of the script code. Like that's probably not necessary. And it can definitely be derived mathematically if we're not going to use it very often. So there's a few things like that that I think actually would probably optimize us down to like 10 single byte opcodes. So that's kind of where I'm leaning right now, but we probably need to argue about it a little bit.
Yeah, so Mark, I think you had some ideas on that. Do you want to jump in?
Oh, yeah, I just wanted to point out one thing, one advantage of the concatenation. I'm not saying this is what we should do it, but the concatenation makes it easy to do. Just, you know, if you did want to do something like a check sig, but you just wanted to make a custom sig hash, then you could do it in, you know, a few opcodes. Just say, okay, give me all these items and please concatenate them for me. And then now I'm going to do check data sig. And there you go. But is that really going to be like the common use case? Probably not. It's probably going to be a covenants thing. And then we do want the pieces separated by default, I think. Yeah. So, yeah, just wanted to point that out.
And on that note, the concatenations, like the group concatenations that are done, at least in cache channels, are not sig hash elements. They're not elements of the signing serialization. They're pieces of distinct messages, one for the rate claim and one for the payment authorization. So they're, even for that use case, it doesn't really fit into it's not optimized by the concatenation functionality.
Mm-hmm. Okay, yeah.
In that particular case.
Yeah. So that's true. So just to extend that, so sometimes you want to do a custom sig hash, but you also want to sign in additional data that's imported from the signer. They're saying, okay, I'm signing, but with this additional parameter. And yeah, if that has to be concatenated in any ways, it might make it awkward. So probably having the built-in concatenation isn't really giving us that much benefit in the end. Yeah. One thing I'm curious though is, like, for example, let's say we have an opcode that gives us whatever other input we want. We can provide the index. It provides us on the stack the input with that index. Do we also want to have the one that returns this hash prevouts and hash sequence, because these are also useful if you want to emulate the sig hash all that signs over everything else in the transaction. So that would mean there would be quite a few more opcodes than maybe just 10. I don't know. I'm not sure if anyone has any ideas.
Yeah, also on addition to that, for some use cases, I was like, okay, maybe it's important to get the last output to be something specific. For example, if that's the output for something, or yeah, or whatever. It also works nicely with like sig hash single, and might be useful to get the number of inputs, outputs, or stack items for an input, and then we kind of get more and more, yeah, more and more of these opcodes, and I'm still more leaning towards, I'm getting a bit friendly with single byte opcodes, but I'm still leaning a bit more towards multi-byte opcodes. It would indeed be a bit more complicated for the implementations, but it would also give us the option to be like, oh yeah, let's add these other features without having to worry too much about keeping it very, like, having to optimize. And also if we then find out, oh yeah, it would actually be very helpful if we had these 50 other opcodes, because then this and that would happen, then we might potentially shoot us in the foot by adding all these opcodes. But it's not like this would be the worst thing. I think it has very valid arguments. Yeah. Yeah. So one other thing that I added in the pull request to Jason's proposal was a opcode called, I think it just called it input data, which is kind of weird and kind of special, and I think extremely powerful for the future, because it allows to read parts of the input script of other inputs. So you could say, okay, give me the 5th push operation of the 3rd input. I proposed it and was like, yeah, I have this idea. It's super useful, but I'm not sure if it's a good idea. And maybe I could ask for some comments from you guys if that would be technically feasible, or yeah.
I don't think it's that crazy, to be honest. Like, it sounds a bit crazy, but I don't see why it should be, like, bad, or like open up any malicious attack vectors or anything. It's just weird. Yeah. So just to paraphrase, this is the idea of inputs reading each other's script sigs, and normally that's like the furthest thing from possible, because the script sigs are like barely attached to the transaction for most purposes, like the sig hash. There's no covenant you can do right now that looks at other script sigs. So yeah, and the reason it's not crazy is right now, with all the consensus rules that we've introduced for malleability, now the script sig is it's actually just a list of byte vectors that are encoded in a weird way. So it's like a canonically encoded weird list of strings. That's all a script sig is now. So there's no reason why it's like hard to look into another script sig. They could all be like pre-parsed before you start running any transaction inputs, for example. Yeah, that's how it is.
Cool. Okay. So do you think it wouldn't be a bad idea to add that, like, categorically? Okay.
Well, I don't see any reason to rush into it, like, but it's a cool idea. Yeah, it might be a little bit annoying to implement at first, because it's not as easy. It's just not as easy to implement as some of the other things. Like the naive implementation would be, you go into the other script, you parse it, you get that item, and then you return it. But then that's like a quadratic attack vector if you just do that every time naively. So you would have to be a little bit intelligent, which means the implementation is slightly annoying, but it's possible. Just more tricky. Yeah. What are there particular use cases you have like something really cool you have in mind that would?
So yeah, one thing that I figured out for B.Cash, it would be cool to have a contract, to have a pay to public script hash. No, to pay to script hash address. We don't have public script hashes yet. And then you could automatically, without any interaction, spend that output by only sending it to the UTXO of the cardholder. Because if the cardholder is offline and you still want to send him some stuff, then you have to be able to verify, okay, this can only be spent by somebody who has a script code of this with this public public key, which is owned by this guy, but by this card, and then it has to be sent to then it has to follow basically the rules enforced by the card contract, and that would allow a very lean and not complicated way to. It wouldn't be a very complicated way to allow that. It is currently possible, but you would have to provide the whole transaction thing. Oh wait, yeah, the transaction, it doesn't work actually because the transaction format is longer than 520 bytes. So yeah, it would allow this thing.
So in that case, you need the script pub key of another input as well, because you would have to confirm that it's the correct P2SH script.
Yeah.
And it's not some other fake script with a similar looking script sig. Okay.
So that would be one that came to my mind.
Yeah, so for importing the script pub keys of other inputs, also, I think that's even easier because I think they're all, like in the implementation, I think it reads all the UTXOs before it starts doing any validation. So it knows all the scripts, it knows all the script pub keys of all the inputs before it starts executing any of them, I believe.
Interesting. Okay, so maybe it would be an idea to implement just getting the script public of inputs first, and then maybe later add stack items. Because I think there would be also a benefit to accessing stack items, because then you could be like, okay, I know this is contract X, and it takes some input, and then I can communicate other values other than the script public. Could certainly be emulated by putting everything in the script public. You know what I mean? And then parsing that. But I mean, the goal is to make it easy, and if accessing the stack items directly isn't too cumbersome to implement, then that'd be cool.
Maybe just getting back to the goal of the meeting, maybe we can. So like, I guess in terms of off push state overall, like, I guess I'd say that it's like something we'd want, if we're coming up with a roadmap, this is like something we probably would want to stick on the roadmap. But I'd say it's like in the early design spitballing kind of phase of development. Is that right?
We went into quite a bit of detail. Huh?
Yeah, that's right.
Yeah.
So,
well, but this points out at least that there might be many opcodes that are interesting. Certainly more than what's in the SIG hash. So
I guess what I'd want to know is, like, when we talk about the other stuff later, if there's anything that would interact with this at all, which I don't see anything obvious. But.
Well, yes. So the one interaction we should think about is if there's ever a new transaction format that continues to use Bitcoin script. And I know, so one idea that's been floated around is that the new transaction format wouldn't have, I think I've heard Amaury say this, the new transaction format wouldn't allow you to do an arbitrary script pub key on outputs. You would be restricted to certain address types. So you can do weird, I don't know, stuff that's non-standard right now. I'm not sure what the advantage of that is, but that raises the question, like, if we do this thing where we get the script pub key of a previous input, how is that going to work in the new transaction format? Which of these things even make sense in the new transaction format if that is introduced?
Yeah.
and that's not even getting into the whole Nimbus thing, which is another script. So what does it mean to get, like, if you're getting the script of another like script system, is that open some attack vectors? I don't know. It's just, yeah. That starts to get crazy.
Yeah, I think if we want to get to that, we should move on to the other opcodes. Or does anyone have some remarks on this opcode?
But as far as interaction with other opcodes in this list, in this agenda, I can't see anything. Yeah.
I mean, I think what I'd propose is that we try to talk next about stuff that's the things that we think would be the earliest, like the next steps potentially, which I would say is stuff like, stuff like the number size, like how many bits are the numbers, things like op-mul and op-reverse, and then maybe the limits, like script byte limits or whatever, script opcode limits and stuff like that. So.
Yeah, we can move on to the 64-bit and op-mul thing now if you want.
Sure, yeah, let's do that.
Yeah, I'll talk a bit about that. Like, so there's one interaction, which is when you multiply two large numbers, then the result can be as large as the square of the largest possible number. So if we do 64-bit numbers, does that mean we're going to allow 128-bit outputs, which is kind of how script works right now? You can overflow on the output, or you can't overflow on the output. It always just produces as large as is needed.
So you can overflow.
Well, there's no overflow. So if you add the largest integer to the largest integer, you get a valid value, which is 5 bytes long. You can't use that as an input on anything further, but it didn't overflow. So it's a little bit weird right now that you can do this. And one thing we can think about, this is one of these interactions, is if we do 64-bit, we can change that concept, and we can say, well, okay, no, you're not allowed to overflow. Like, the results have to fit in 8 bytes now. And that would be backwards compatible because everything until now has just been add and subtract and whatever. So nothing has gone over 8 bytes on an arithmetical output, unless you count op num to bin. But let's leave that aside for now. Yeah, so we could change that theme and make it so that overflow is not allowed. And then op-mul would be easier to implement. You know, all the C compilers have a built-in for doing 64-bit multiplication with overflow detection, so it's trivial. Yeah, or you could use 128-bit integers, whatever you want to do. But
yes, okay. So let's start that conversation. So I think most people here are like, if we were to ask them, they would be like, yeah, 64-bit numbers are like, of course. But there are some arguments to make for 128-bit integers. So I think one of them would be that then you could, like, what I came up with is that you then could use the full range of SLP outputs, because the 64-bit integers would be signed, so they wouldn't be able to represent a full range of unsigned 64-bit integers.
Yep.
Which cuts out some parts, but I mean, if one of the reasons to implement it is allowing SLP covenants, then I think it should be like, okay, you can express every number. And another one would be if we do add sub-Satoshi or fractional Satoshis to Bitcoin scripts or to Bitcoin transactions, then having that precision in the math would be pretty good. And the last thing would be if you're doing complex like financial stuff, and then you want to do some computation, and then at the end maybe truncate it to 64 bits back again, then not having to worry about all this precision in the steps in between, which is what you have to do currently. And Emergent Reasons has told me about the hassles they went through with doing that. So it might be, if it's like not too bad of an implementation, to go with, okay, let's go non-overflowing but 128 bits, not bytes, bits, integers, then it would have some, it would have some additional advantages. And also for browsers, they recently, if you want to verify that in browsers, then you would, with JavaScript, you would be stuck with 64 bits because you can't use 64 bits, except in new browsers, you have a big integers where you can do arbitrary integers. So at least for newer browsers, they wouldn't care at all about the bit size, and they're backwards compatible libraries for that as well. Yeah. What are your thoughts, Mark, on that?
I see.
On
well, go ahead. Yeah, somebody else. Yeah.
Oh, yeah. On that note, on the JavaScript note, Bitcoin TS currently implements all math using arbitrarily sized integers and then limits them now. So it's actually already written as if it supported 128 bits, and we just have to bump the number.
Yeah.
Yes.
So certainly that is an argument for removing the overflow, the way the overflow is done right now, like making it do overflow errors. If we do plan to go to 128 bits, we'll probably want that anyways. So, yeah. Okay.
Rosco?
That's maybe another use case that I can think of. I'm not sure how realistic it is, but like if we're gonna maybe be using oracles to bring in data from other chains that might support larger numbers, I'm not sure if having a larger number like a 128 will also help us with like interoperability in that case. What do you guys think about that?
Yeah, Ethereum uses 256-bit. So if they would restrict their numbers to half the bit size, then we could use them out of the box. But if they don't, then we're like, I mean, we could add like, okay, we split and have two numbers and operate all the math with two numbers. But I think that's at least some consideration.
I always found that amusing about Ethereum, by the way. Do you think that was a good design decision that they made with the 256-bit math? Like, do people need that? I'm just curious, just as a tangent.
I'm not sure either.
What are we missing here?
It's really necessary, but I mean, I think 128 is usually enough, right?
I guess a question maybe for Mark, like, so if we change the overflow of mul, I guess that would basically, so would that basically cement that limit in? Like say we say, okay, we're doing 128, but then it can't overflow or whatever, however you call it, it overflows. If it goes above that, then you couldn't really bump it again later, I guess, right?
I think you can bump it because if you bumped it from 64 to 128, you would be strictly adding functionality, so it wouldn't stop. Like all the previous scripts that would have tried to use 128-bit integers, they would have just failed and they never would have got on chain. So you're just making.
But it would change the spendability maybe of some script.
Yeah, it would change unspendable to spendable, which is something we do fairly often. Actually, yeah.
Okay, well, that's something to keep in mind. So, okay, so just for me trying to document everything, like, so integer size, is that so it affects all mul? Does it affect, like, what else does it interact with? I guess,
like every arithmetic opcode, like op add, op diff, op num equal, like all arithmetic. I think they're around 10. I think I counted them, but I'm not sure.
But they're already there, right? So
that's, they all have to be changed.
Yeah.
And just another thought, because Toby, you said that one reason for 128 bytes would be like full range of SLP transactions. Just throwing it out there, is it like, could it be an idea to differentiate between signed and unsigned integers? Is that a bad idea? I don't know.
Yeah, I don't think it's worth the extra complexity. Like, I think you'd have to end up adding a whole new set of opcodes that take unsigned integers effectively to do that. Yeah.
All right.
Yeah. I mean, I guess the one way to do that would be just to have all new arithmetic operators that treat it as unsigned, if you want to do.
Yeah, the issue, actually, so it's funny, the issue there is if you make unsigned operators, I mean, presumably they're going to act like unsigned integers in other languages, which they're actually modulo integers. And you can't increase the bit length of those because you will be changing previous behavior that if it relies on the modulo wraparound behavior, right? So yeah, so one of the nice things about signed integers is if you specify that they don't wrap around, then you're free to increase the size. Whereas unsigned integers that are modulo integers, you're kind of stuck with whatever you choose at the beginning, unless we decide to make them non-overflowing unsigned integers. But I don't know. Then all you're doing is you're just removing a signed bit, which is, like, it's that, yeah.
Might as well add another bit.
Yeah. True. Yeah.
It's to 65-bit integers.
Yeah.
Like a great
Actually,
idea.
SLP goes beyond 65 bits because you have to add up all the token amounts for all the inputs, and that can.
True. So it's technically arbitrary size integers.
Yeah.
Okay. I don't have any more comments.
Yeah, I guess I'm just trying to think of what's, like, I don't know if we should talk about other stuff first, but like where does, like, to me, this seems like something that people want to do. So I just don't know where it fits in terms of like a roadmap or how it affects other things. I guess it's not that urgent, but it seems like something that would be kind of nice to have.
Yeah, well, you should ask you guys what do you guys need? You guys are using this stuff.
Yeah.
What's like the most pressing issue, right?
So maybe about 64 bits. Is it really needed? Well, people are really struggling with with this. Mostly emergent reasons with his contract, and well, my contracts, I mean last will and Mecenas just right now just fail if the value is over value on the contract is over 21 bitcoins. Yeah. If you want to create a mecenate for someone that is over 21 bitcoins, then it just fails. Yeah, you can obviously cut it in parts and make a few mecenates, or just put many UTXOs on the same contract, but you know, well, that's not very user friendly.
It's the same with B.Cash. So if you want to use Bitcoin as your token, Bitcoin Cash as a token of choice, then you can only have a maximum of 21 Bitcoin Cash on your card, which, I mean, compared to credit cards, is kind of limiting. So it would be cool to have a wider range of integers there. So, but for me, more important is the 201 opcode limit, because to do some like Merkle tree checking, like that eats up quite a bit of opcodes, and doing the like OP reverse emulation also eats up a couple of opcodes. So I think those two are my most pressing issues, so to speak.
Oh, maybe we can move on to those items. Is that the next one?
Yeah, sure. Let's do that.
OP reverse, or
there's the op reverse, op roll, and op reverse, and yeah, we can talk about op reverse now, I guess. Just leave aside the op roll for now.
Yeah, like I guess maybe just talk. Well, can we like op roll, it seems like it's not that urgent, or no one's really asking for it, as far as I can tell. Reverse op roll, or should we just?
It's nice for like better compiled code from my side, and I think Tendo is the same thing, but like it's not urgent. It's just sort of a nice to have, but I don't think that there's anyone else sort of having that pool.
Mm-hmm.
Yeah.
Is it like a total game changer in terms of bytecode, or it just like saves 5% or something? Like
it's very situational, I guess. So right now, basically, whenever you reassign a variable in Cash script, what I do is I just put it on top of the stack, and I treat that new variable as the new value. And then at the end of the script, I just drop the old variable because it's no longer needed. But if you're in a conditional branch, then you want the stack to look the same no matter which execution path has been taken. So in that case, I have to like do a drop-in replacement of the old value. So in this case, that's just like kind of digging into the stack by going to old stack until I'm there, and then put the new value there and pop everything back. So that's actually a very, very expensive operation.
So actually, you wouldn't prefer reverse op roll. You would actually like a swap that happens with arbitrary depth. That would actually be better for you.
That would be even more efficient, but I think less flexible.
Yeah, that's true.
Yeah.
Yeah. So, Karol, did you want to say something?
Yeah, I wanted just to say that I talked to Tendo Payne with about this opcode, and he needs us to implement the Koopman stack optimization, and well, I think this is quite important because high-level languages on top of script is how it will be done in future. I mean, people won't be digging in script directly.
Nobody.
And I think that's well, that's for scaling. That's important for scaling because scripts will be smaller. That's important for user experience and how powerful can the scripts created by high-level languages can get, right? Because I mean, we can't just increase the bytecode limit forever.
Speaking of that limit, like, so my understanding is that op roll is one of the things that is problematic when you start increasing limits. Is that so? I don't know. Like, I don't know if this would add to that, or if it's any worse.
No. It's for optimization of scripts generated by high-level languages.
Yeah. But there is a quadratic cost for op roll, and for op reverse roll, it will also be the same.
It'll be the same, basically.
It wouldn't
right?
be any worse, but
okay, yeah. But I'm just thinking of like attack things, not what people wouldn't use normally.
Yeah.
So, yeah.
One thing we can think about is regarding that attack is maybe limit the op roll depth to something smaller.
Yeah, or limit the number of op rolls you can do in a script. Because I mean, if you limit the depth, then it kind of gets, more useless.
In the way of, yeah.
Because that's the whole point of op roll. But yeah, maybe for op reverse roll, one thing I thought about, because for Nimbus I had a big look into stack-based languages, so mainly JVM and WebAssembly, and they both take a different approach to this. So the extreme case would be WebAssembly, which doesn't have any opcodes for changing the stack items, just shuffling them around. accept OP dupe. Instead, it has local variables where you say, okay, put the top stack item into these registers, and you have an infinite number of registers.
Which language was that again? You said?
WebAssembly it was.
WebAssembly.
Also JVM has the same thing, but JVM has some it has more like OP swap and drop and to drop and like all these other opcodes we know from Bitcoin scripts. It has some of them, but WebAssembly would be an extreme case, which doesn't have any of these fancy stack item opcodes. And I think if we going the route of, oh yeah, we have still 70 opcodes left, then maybe we could be like, okay, let's add 10 opcodes that set a local variable, each for their own slot, and 10 that read the value from that slot back again.
Right. So using the alt stack for this is also awkward, right? Because if you want to use the alt stack, you'll have to like dig through.
It's very awkward.
Yeah. Unless you have only one, then it's great.
Yeah.
Hey guys, we have registers. We have one.
You have one register. Yeah. Is that enough, you guys? Come on.
Yeah.
Well, I'll add that
one.
Of ideas. You can have a new thing for my list here, Tobias.
Yeah, that's an interesting idea.
I wanted to write about it earlier, but I already had so many items that I didn't want to. I don't know. I didn't.
Yeah, and that's one of those things that like obviously has no performance penalty. It's very cheap to implement.
Non-quadratic. It's basically constant.
Yeah.
One thing, just looking at the time, we've been talking almost an hour. Like I was thinking, maybe we should try to wrap up all the like whatever I call it, like phase one stuff. Like talk about op reverse and that limits and things, and then maybe save the Nimbus and all that kind of stuff for another meeting. Does that sound reasonable?
Yeah, let's not do Nimbus today. It's like a alien netherworld thing. It's too much. Yeah. So op reverse.
One while we're still thinking just a little bit of it, one thing, this may be abundantly obvious to everybody, but that is interesting is that we only have 70 free single byte opcodes currently. But that's another thing that we're actually able to modify pretty easily in a version number. So if we switch to a version 3 transactions and choose different code points for every opcode, we can actually choose new code points for opcodes that are actually useful in future transaction versions. So if check sig is used if there's some opcode that we choose to, if we have to expand to use multi-byte opcodes, but there's a multi-byte opcode that we use a whole lot, and there are other single byte opcodes that we don't use very much, it's actually a pretty simple optimization problem to just look at the chain and see what's most used and choose code points that way for a future transaction version. So it's just to keep in mind, it's not something that we're necessarily writing in stone. It's just a serialization format. Once you're changing transaction versions. So something as an aside.
Yeah, I mean, there are advantages to sticking with the same script opcode numbers. I'm just thinking like consider on Bitcoin Core they have SegWit. They introduced a new transaction version. If they had at the same time introduced a new script version, it would have been much bigger change. So, but they are planning to do that with. I think they are planning to do that with the next SegWit version, right? A new script system, I think maybe. I don't know.
I don't follow.
As far as I know, they're not doing any code point changes.
No, okay.
But just because they haven't run out of code points yet that are single byte code, I kind of doubt they ever will actually at the current rate. Yeah. It'd be sometime in the year 2100 or in this 22nd century. But.
Yeah, well, it is nice. It is nice if you don't run out of single byte code points. It makes it easier.
It is very convenient. Yeah.
Okay, yeah, let's move on to OP reverse. So I proposed it because I ran into problems with doing big endian numbers in SLP. So obviously a lot of people are talking about SLP 2.0, which will change the endianness as far as I know. but I think we're still kind of stuck with not OP, with SLP 1 and will for quite some while. And so I think if we want to connect SLP and smart contracts, then OP reverse is kind of important. And OP reverse, yeah, full stop. It doesn't have too many other use cases other than tapping into big endian oracles, but I think oracles can much easier be changed than the SLP version.
Yeah, I think at first it just created a weird reaction when you proposed it, because you're like, let's add this opcode because of SLP, and that's the only reason. And it just sounded weird at first, so I think maybe you just got off on the wrong foot with that. I don't know. I think it's a reasonable opcode. Just we shouldn't justify it as that. Like, I'm sure there are other use cases actually besides SLP and big endian oracles. There's surely something else. It's just such a generic operation, reverse array of bytes, right?
Could also be like for cross-chain interoperability again.
How's
data.
Is there like a quadratic exploit there, like reversing array of bytes?
It has linear cost, so
yeah. So as many times as you
like
can execute
cat or numbin, which all have linear costs.
Yeah.
And in terms of like integer size, I guess it would be pretty easy to just extend it out as needed or whatever. Like say you did op reverse
limit the length of op reverse to something small or something like that.
Well, I don't know. Like, is it limited by the integer size or not? Or not really.
It would be a byte array flip, right? It wouldn't be a numerical opcode, as far as I understand. Yeah.
Oh, one use case that just sprung to my mind spontaneously was that in the token, it's also SLP related, but let's stick with that. So the token hash in SLP is currently big endian. So the first byte of thing is at the beginning, but the hash coming from the out point in a covenant is little endian. So being able to just reverse that and then equal verify would also be useful. So yeah,
okay.
It's big endian. I think that's the main. And I mean, I already said you can check for palindromes very easy, but I haven't found a particular use case for checking for palindromes.
Yeah. That's interesting. Yeah, that is an endianness thing. It's yeah, interesting. Good, you pointed that out. That I can imagine that's another sort of common thing that people will want to do, because it is common to want to encode the TXID in the order that it's presented as hex, rather than encoding it in this weird reversed way that it gets encoded in the transaction. Yeah, so interesting. So that would be an argument for at least allowing 32 bytes, for example. Yeah.
So is there any, so I guess in my mind, like in terms of what you wanted, Tobias, I see this and like increasing the limit of opcodes as sort of related, just in the sense that this takes a lot of opcodes kind of pointlessly to change the endianness. So which of those two things do people think would be like a better thing to do first? Or which one is like a more palatable thing to want to do? Because I don't know, I can kind of see both arguments. Like it seems like nice to have a script system that actually works.
Yeah, so if we
increase the limit and put all kinds of stupid stuff in there that doesn't really, is totally inefficient. You know what I mean?
Yeah, so if we raise the opcode limit to say 400 or 500, then we obviously, it would allow easier like byte shuffling, like OP reverse does it.
Yeah.
But it would also increase the attack surface to quadratic attacks. I still think we should do it. We should raise the opcode limit because that adds some more use cases. Maybe not too much, but 200 feels very, very restrictive in my opinion. If we want to raise it like to 500, then we should limit the quadratic opcodes like op roll. We talked about that. Maybe we limit it to maybe 50 or 100 or 200. If we limit it to 200, then it would still be the same. It wouldn't limit any existing scripts, but it would limit the attacks done on quadratic exploits. Yeah, and also OP code separator also would, I think it should be limited to maybe 1 or 2.
Or 0.
Or 0. So SLPDEX and B.Cash currently uses it, but only as optimization for like this push state or OP transaction info.
Yeah, I don't think you should need it more than once, really. Yeah. Interesting. Yeah. Well, so just to go along that, Antony, you were asking about which is better, like increasing the limit or the op reverse, if you had both, or like if you had to choose one. But like this TXID, for example, that would be really annoying to reverse using just regular opcodes because it's 32 bytes to reverse. That's huge. So yeah, that's an argument anyway for having that independently of the increasing number of opcodes.
I think those things are like should be evaluated independently in any case. Like even if we do or don't have op reverse, I would still advocate for increasing script size limits. So yeah.
I think the way forward here would be to test different scripts and see their performance, which I already tried to do, but yeah, I annoyed Mark Lundeberg a bit with my script bugs, but
it's hard to do. It's hard to do very nicely, this sort of benchmarking.
Yeah, maybe it would be a good way, a good time to be like, okay, let's do it a bit slightly more thoroughly. So we're like, okay, what's actually the performance costs and stuff like, because we don't want to end up like splitting the chain, because not splitting the chain, like splitting nodes because they can't keep up.
Yeah. And that's interesting though, the idea you said about limiting op roll to 200, which would be perfectly backwards compatible. That's an interesting point. I was thinking of a much smaller limit. Yeah.
A smaller limit. What would you recommend?
Well, something in the around over order 20 or something. Something like that. But maybe that's too restrictive for the compiler guys, right? Interesting. Yeah.
Okay. Yeah.
Well, so besides op roll, there are also other things that are kind of expensive, like even just pushing a bunch of 520 bytes items and hashing them. That's SHA-256 or hash-256, the double SHA-256. Even that is a bit CPU intensive. So we can get rid of like the quadratic-ish things, but there's still some expensive things that are just linear.
Yeah, I think it's pretty interesting to see that like double SHA-256 has the same like price in terms of size as like swapping to or dropping one stack item. And I think for the new transactional version, we should, that's my view, we should strive for being to having the cost of the execution be equal to the actual execution time. So it's currently, the current design of script limits this, because there are a lot of operators that have non-deterministic cost, like OPCAT or like a lot of them. But it would be worth to like keep in mind on that, because then we can raise the limits more, like we don't have to worry about, because we know exactly how much nodes will have to be able to do.
I'm thinking
that tangents into like this alien world of Nimbus.
Yeah, I know. We're getting into the 2.0 ideas now. Like, it seems like we're maybe kind of at the end of talking about all the like the like, I don't know what to call them, the script 1.0 type ideas. Maybe we should wrap it up soon. I guess what I was thinking.
And maybe some action items.
Yeah, like I could put together basically a list or a roadmap based on what we said in the meeting. Just kind of categorizing these things, maybe, and I'll just share that with the group. And I don't know beyond that what. Does anyone else have any action items they can think of?
Yeah, I'm just thinking there's one. So I'm working on this new signature checks counting system right now, and that is like it has a similar idea as the opcode limit. It's trying to limit CPU usage, and I'm just thinking about like what are we going to do down the road? Presumably, there should be some sort of better counting system that doesn't just look at signature checks. It maybe combines these two ideas into one. But I can't imagine exactly what that should be like right now.
When you get into like a Ethereum gas type situation, essentially, right?
Yeah, I mean that's effective. If you want to start tracking different opcodes by their cost, you have to do that. It's just it probably makes sense to only have one cost for CPU usage and not have distinct signature checks cost and then opcodes cost. It's a little bit weird to have both. So probably down the line, we probably want to merge those anyways, I would guess.
Yeah, at least for the new transaction version. Because for me, it was very hard to come up with anything that's like good to do something like calculating gas costs, except assigning random numbers for linear opcodes.
Yeah, that's all you could do basically. What would change in the new transaction version? What would make?
Do you mean for Nimbus? I proposed doing like for WebAssembly, all opcodes are constant cost. So if you disregard CPU caches because they screw everything up regarding performance, but all of them are have some fixed cost, and if you just add it all up, then you get the cost of
I see.
The whole thing.
So basically somebody has come up with this list of arbitrary numbers for you already.
Yeah, that's a good thing. That's a good thing about WebAssembly. It's like, yeah, here you go. We spent whatever many man years on this, and it's pretty optimized. That's why I think moving towards WebAssembly would be a good idea to do. There have been some concerns about the license, but it's licensed under Apache 2.0, which I think is fully compatible with MIT, so long as you,
maybe we shouldn't get into it, but I mean, just my worry is that it's complex and, consensus failures. That's what I'm worried about. That's the only thing that really worries me about WebAssembly. If there's some consensus failure because different versions have slightly different implementations, then you get a chain split.
Oh yeah. So, I mean, WebAssembly is well defined, but there's still like Mozilla doesn't care too much if their version is slightly different than Chrome's version.
Exactly.
But we do care very much. So that concern they try to mitigate, but the incentives aren't perfectly aligned to be mitigated.
Exactly. Yeah.
But for initial versions, I still wouldn't say, okay, let's use a compiler for WebAssembly, because compiling is not very fast, especially for scripts that are only like a couple of 100 bytes long. So interpreting them would be, I think, should be the default option, and then only if we see, oh yeah, this script is actually, I've seen it 10 times now, let me compile that. Or there might be some DOS attacks there, but we could come up with some mechanism to be like, hey, let's compile this into efficient machine code. But yeah, I think we should do this in a separate targets. It's a lot to unpack, and I've got some crazy ideas. Not how to change script, but what we could do based on those changes.
Yeah, just based on looking at my clock, I'm thinking maybe we should save all the other crazy ideas. We should definitely have another meeting maybe in a little while, in a few weeks or something. Would you guys, is everyone okay with basically wrapping up? I'll try to basically write up notes on all the things we talked about and then open it up for feedback.
Yeah, I think the next step would be for each item that you will write down, to just write a proposal, like, and then people can put it on GitHub. Maybe we could, there is some repository for that already. Maybe we could get that directly in there so we can make changes there, maybe on a different branch or something, so it's not, that doesn't have this official stamp yet. Yeah, and then people can make pull requests and stuff like that.
Sure. I mean, it's kind of like most of the stuff is still at a pretty preliminary stage. So, but yeah, I'm more into like getting everything. Yeah, I don't know if it makes sense to pull requests, like to do a GitHub thing yet or not. Like, I'm not going to write up specifications for all these things right now.
No, but like for, like it would be cool if for all these things there would at least exist some place where we could do pull requests.
Sure.
You know what I mean?
Okay, yeah, I'll see. We'll see what we can probably find something that works.
All right. Well, thank you guys very much for coming and making this possible today. And it's a first step towards having regular script meetings, and I think that's a really good idea. So, thank you guys.
Thanks, David. Bye, everyone.
Thanks, guys.
Bye.
Thanks.